Yeah, I work with, fortunate enough to work with Christian on a variety of Kokkos things. I'm sort of backdoored into the Kokkos project a little bit through this co-design effort, and that's under this sort of Vanguard project umbrella. So this talk is not about, for a specific application, is it faster on Grace Hopper, MI300A, or what does the performance look like on Next Silicon or something like that. This talk is about sort of the mechanics and how the structure is set up, at Sandia to enable these collaborations to exist in the first place. So I'm not going to be like presenting results on a scientific application or something. This is kind of like a project management talk a little bit, I guess. But basically, I come to this through these two projects. So Kokkos is this performance portable programming system. But for the purposes of this talk, Kokkos is sort of a static portable API that allows that we use as a vehicle for co-design with the vendors, right? We have a bunch of stuff implemented through Kokkos. So if the vendors can get Kokkos working, then they can run a lot of applications. And we have this Vanguard project, which is sort of overall about expanding, what are viable products in the HPC ecosystem and accelerating the development of technologies that seem like they have a pathway to be successful. So I thought I would just very briefly, I think maybe if you've been in this room, you saw basically a version of this slide earlier today, right? So this is kind of where Kokkos fits into things. So Kokkos presents a public API, and I'm not going to go into this in detail, but there's basically parallel execution primitives, and then a system for managing multidimensional arrays of data that those parallel primitives operate on. And so that's the API that Kokkos presents to, the application developer and so on. And then on the side of the Kokkos team, and in collaboration with the vendors in some cases, we're responsible for implementing what we call backends. And this is the translation layer between the Kokkos public API and whatever the specific architecture target is. So Christian had on his slide parallel 4. So the backend, the CUDA backend, is what converts that parallel 4 into a CUDA kernel launch, right? Converts a view allocation to a CUDA malloc, right? So we have a different backend for every different sort of class of architecture that we target. NVIDIA GPUs, Intel GPUs, AMD GPUs, OpenMP, P-threads, serial CPU execution. And sometimes when we're lucky, we get to work with vendors on backends for architectures that are not broadly known. So I thought I would just start off by hopefully getting a few disclaimers. My slide is blank. I have no disclaimers. All right, so no problem then. My whole thing seems to have frozen here. I'm sorry. I don't know what's going on. Okay, I don't know. I don't know what I did or didn't do. So one thing, and I'll talk about this a little bit more, but a lot of these interactions are with products that are not released. They may never be released. So a lot of it's covered by NDA. So for that reason, I really am not going to be going into specifics about any particular vendor interaction. So sorry. I know that's interesting stuff. I am not standing here as a representative of any of the vendors. So I call them vendors in this room, right? So that's your AMDs, your NVIDIAs, your Next Silicons, your HPEs, what have you, right? So this is my understanding of some of the things that have been relayed to me during my time working on this stuff. I'm going to sort of frame things in terms of our efforts at Kokkos, but I think lots of people have a variety of open source projects, whether you're coming from the lab side or university side or even the vendor side, right? So think, if you're responsible for a project, maybe you can use your own creative faculties and draw an analogy yourself. And of course, I mentioned, the vendors and our partners are all awesome. So this is not a criticism like anyone's particular process. This is more about friction that can sometimes happen at the interface between two different teams, right? It's not that anyone is necessarily doing anything wrong, quote unquote. It's just everyone has their own particular set of interests and way of organizing things, and sometimes there's friction there. So I guess one question is why do we even interact with vendors, right? I mean, they provide, right? NVIDIA provides CUDA, so what do we need them? They did it, they threw it over the fence, what do we need them for? So on the Kokkos ecosystem side, I kind of think about it this way. We get relatively early support for novel architectures, right? So that's a benefit for us in the entire ecosystem. If we have these kinds of collaborations with the vendors, it's easier for us to get support from the vendors, right? We have established contacts there, technical people that we built up trust with. We already have points of contact for specific areas that we have problems. So if you're in the Kokkos ecosystem, you indirectly benefit from our connections with the vendors. The vendors are the experts in the products that they sell, so we leverage that expertise so we can get improved performance. This also prevents us, I think this last one's kind of interesting, from falling into any particular trap about being too vendor specific, right? So this basically, right, if we know things work across AMD and Intel and NVIDIA, or AMD, Intel, and NVIDIA GPUs, or we have some confidence that generally our abstraction is like pretty good, actually portable, stuff like that. So on the vendor side, why would a vendor bother doing this, right? Their time is expensive as well, and they would need to assign staff to work with us. So what does it seem like they get out of this whole thing? Kokkos serves as a single place of interaction for many different vendor customers, right? You get things working in Kokkos, and all of a sudden, the whole world, right, of the DOE and the various Kokkos ecosystem is available to you, right? Kokkos also can serve as a regression test, right? We use relatively sophisticated C++ features relatively aggressively. We have a pretty broad test suite of various capabilities. Kokkos is a thing you can just download and run in your own CI, right, as you're doing your compiler and your toolchain work and what have you. Kokkos is a successful project, I think it's fair to say. We have a programming model that works for people. So to the extent that a vendor is trying to figure out what is a productive and useful and potentially portable programming model, right, we have an example of one. And so this kind of goes with the regression test thing, but if you support Kokkos, you automatically, hopefully, are supporting a lot of different applications. So I mean, the main point of this is that, right, these collaborations really have to be a win-win for everyone, or they're not going to go anywhere, right? If both sides don't think it's productive work, it's not going to be happening. So it truly, I think truly these kinds of interactions tend to be productive work for these reasons, and everyone agrees with that. So from my perspective, it kind of falls on a spectrum. On the left, we have what I'll just sort of file under co-design, but it's basically things that are like riskier, longer term. You do a lot of detailed technical coordination with the counterparty. On the right side, it's more for established things. So, if NVIDIA goes from CUDA 13 to CUDA 14, right? Mostly things kind of work. Maybe there's a few bits and bobs here and there that we need to make some adjustments around, but we don't really have to talk to them that much. Everything kind of is just chugging along in the normal way, right? And so there's all kinds of stuff in between. So I just have a few examples. So this is kind of more like maintenance-y type projects, like fixing compiler regressions, tuning architecture parameters for a new CPU or GPU, things like that. In the middle is something like, just imagine that we have like a new GPU vendor come on the scene, right? I don't know, the company out of the EU or China or something, right? And like in principle, it's kind of comparable to AMD or NVIDIA, but we just don't have a back end yet, right? So we probably have to talk to them some, but in principle, everything should work. And on the left is really where like the kind of cutting edge and interesting research happens, which is like, it's not really clear that what the vendor is trying to do is really even compatible with Kokkos. Maybe Kokkos needs some extensions. Maybe if the vendor just adjusted a little bit of something about how their compiler or runtime works, the support would be much better, something along these lines, right? But that is much more risky, much more uncertain, requires a lot more detailed communication between us and them. So we have had collaborations, and have had collaborations in all of these areas over the years. So I have a list of collaborations here so this is all before my time, so please don't interpret this talk to be commenting on these specific collaborations. I had nothing to do with any of these. But just like we have a long history of doing stuff like this at Sandia. So this date is sort of roughly when the system came online or whatever. So much work happened before 2004 on this project, right? So this was a collaboration with Cray. This was an ASCII supercomputer architecture that came out and Cray productized it. There was a Knight's Ferry testbed. So this was kind of a precursor to Knight's Corner and Knight's Landing, some of the like Intel many-core systems. And there was work on the MPI implementation and the lightweight kernel and the runtime system. We've had a long collaboration with AMD as they refined their various GPU programming models. So back in the APU days with like Llano and Trinity and so on, there's HSA model, ROCm, and now the HIP backend that anyone who's running on El Cap or Frontier is familiar with. There's the first ARM-based supercomputer came out of this program. So Astra, there was a lot of work in the Linux kernel and the networking stack to get Astra working. And so, the point is that like these kinds of collaborations, I think, are critical to the work that Sandia does and like HPC enablement, right? So a lot of this stuff happens before these systems, before anyone uses the system. The fact that you can just run, for example, the HIP backend in Kokkos, right, is a result of years of work ahead of time, collaboration between Sandia and AMD, right? Just as an example. And obviously, this is all highly technical, detailed collaboration with the vendor, right? So they've been excellent partners along the way in all of this, and a variety of different vendors and companies. So I thought I'd start with what I thought all the pieces of a collaboration were. So the first part is the technical part. So this is where I maybe file myself under researcher if I'm lucky. I file myself under engineering most of the time, maybe. Also from the counterparty side, right? They're engineering teams that are delivering the product features. So the other thing is that, and I hope this was apparent from the previous slide, is that this is not like a 10% effort on the side when you're done with your main activity, right? This is a primary focus of multiple people at the participating institutions because of the amount of technical coordination that's required, right? So the institution, for this to really be successful, the institution needs to be supporting it. You need to have some senior people on the team who have some experience, who can, get you going in the directionally correct direction to short circuit various decision processes. It's great to have, managers on board with the thing because they're going to want to be involved in like the coordination with the vendor and the relationship with the vendor, right? So this is not just, maybe if you're very fortunate and you're very early on, you can start it up, you have a colleague somewhere and they have a promising thing and you sort of start it in your side time, right? But when it evolves into something real, it needs to become an institutional effort. And kind of the same thing on the vendor side, right? I don't have as much visibility into this, but obviously they're sitting down on the vendor side and saying, this is something that we're going to get an ROI on, right? Even if it's not this quarter or this year, right? It might be in 5 years. And so they're doing the rational thing. They're committing resources based on what they think the ROI is going to be. So they need to think that there's going to be an ROI. I think this last point kind of goes maybe, or at least it wasn't apparent to me, at least in the beginning, but there's sort of a lot of allies that you're going to like gather along the way and take advantage of and abuse to some extent, right? So I particularly think like the sysadmins are under here. So these are like the poor people who, you're calling them up because the flaky thing doesn't work and they need to reboot the node or they need to install the neutral chain or whatever, and it's sort of like maybe not their primary job function. But if you can get like some of these people to be enthusiastic and invested in the effort, that'll save you an enormous amount of time. And then we have like the people on like the business and legal side, right, who are also going to need to be involved, and maybe you're going to need to be conversational with them. Or if you're not at the beginning, you might be by the end. And then the final thing that sounds kind of trite, but I think it can actually be kind of challenging, is it's not always obvious like what success is. And that's just partially because there's always another problem you could be solving. So to have some idea of, when do you think you've achieved something with the collaboration, right? Like, what are you aiming for? Is it running a particular driver from your application, right? At the end of the day, like, what are you actually aiming for? So I think if you have these 5 pieces, you're in pretty good shape, and this is what you want to be aiming for at the beginning. So I thought I would go into just a few things that I personally have experienced challenges with in these kinds of collaborations. So I've got, 4 or 5 of these. So this first one I called misalignment of expertise and sort of ownership of a particular feature. And so in my experience, kind of the way this manifests is that, right, the vendors are investing in things based on the market trends, as they should. And our needs, right, don't necessarily align with their needs. Sometimes they do, in which case great, but sometimes they don't. Maybe we need something sooner, or maybe what we need is kind of niche compared to where the main market is at. And this is not just because like someone is, incompetent or whatever. This is just, standard group project stuff. There's sources of friction in like if you're trying to communicate requirements, but the other party's not really understanding. But really another problem that they have is that what you need, the vendor may not have the expertise to provide, and vice versa. So So a concrete example of this is maybe an MPI or like a sparse LA pack or something like that, right? Where at the national labs, we have a lot of people who are really expert in numerics, but they're not expert necessarily, or the same people who are expert in numerics are not expert in like GPU architectures, right? Especially if it's a new computer architecture. No one except people at the vendor expert. And so the vendors need to be sort of responsible for providing, a fast implementation of certain math libraries, but the expertise sits on our side. And so this is kind of, this is a challenge, right, to resolve this kind of thing, but fast math libraries are crucial for the work that we do, right? So, it's a high priority thing. The other place that I've kind of seen this crop up is like the people who develop applications, they have like particular workflows that they go through to evaluate the performance and improve the performance of their kernels and certain tools they're accustomed to using. Maybe they work in a classified environment, they don't have network access, stuff like that, and the vendors don't necessarily, especially if they're not an established HPC vendor, right? They are not necessarily aware of these constraints, and they just have, how would they know what your day-to-day looks like working on, Sierra or whatever, right? So this is a thing that, can be a point of friction where we know what we want. They are the ones who have to implement what we want, but they don't have the expertise or the first-hand experience with implementing the tools that we want. So I think the real solution to this, and I'll allude to this a couple times, is that it's really important to get shared artifacts going quickly. Another challenge here is NDAs. So I mentioned this at the beginning. So oftentimes, right, if we're collaborating with a vendor, of course, we'll have an NDA, but maybe we have a university collaborator also who's in the mix. And if we're lucky, they'll also have an NDA with the vendor, but it's not the same NDA. It doesn't necessarily cover the same stuff. And even if we get permission from the vendor to talk to the collaborator about the vendor stuff, we still can't talk to them about our stuff without an NDA. So a lot of times the solution to this is like, there are things that you can share. I think sometimes people have the tendency to be like a little conservative in what they're releasing, but there are things that you can share publicly. You can get a proxy application, you can sanitize some of your technical outputs to remove site-specific information or something, but if you really do anticipate that there's gonna be 3 parties sitting in the room at the same time, I'd really just encourage you to get on the NDA thing, as soon as possible. So I guess I mentioned that. So the other thing that happens is some of these collaborations are long, and that means that change happens during the course of the collaboration. So I just threw a picture up here. I picked a random public company, which is not one of the ones that we have a collaboration with, but you can see over 5 years their headcount more than doubled. So of course, what's going to come with that is changing priorities, changing products, people come, people go, and of course this happens on the lab side too as well, right? So it's not just like the vendors have changed and we don't. But specifically when we're working with a vendor, right, especially if we start early, in the beginning, in some ways things are very streamlined, right? If the founder is on board, the founder says we're going to do X, Y, Z with Sandia, that's what the company's doing. When they get big, everything is different, right? You're interacting with more than one team, your compiler, vendor, or compiler, libraries, MPI, customer success, what have you, right? They have like new JIRA tickets and whatever to like structure their planning and so on, and a legal department that wants to weigh in on things. And so the project the structure of the collaboration changes as the thing evolves, right? You think you have a good thing going, and then all of a sudden, there's new people in the meeting, and they want this and that, whereas before you just felt like you were doing some stuff. And part of it is just maturing. But in any case, the real solution to this is that you can't rely on any individual person to be like the champion of any particular part of the effort, right? Everything has to be at least 2 people. You have to have a common view of what the shared commitments are, right? It can't just be information hiding in someone's head. And this is good advice in general, but I think it's crucial in contexts like this. I've also had some friction of different planning cadences. So in research, we maybe think about like the budget for the fiscal year, and you just kind of do whatever as it comes during that fiscal year, right? Wherever the results take you, right? And that is not typically how engineering-oriented products work. They'll have like quarterly planning maybe, or some time frame planning. They'll do the planning for the next quarter and the previous quarter. So actually what they want is your input, several months ahead of time on the particular thing that you need delivered. And so obviously this is like a source of friction. And again, the solution to this is, and some solutions to this is like be pretty clear about what it is that you want versus what you really need to be successful. You want to structure your own research so that you're running into problems as early as possible, which is probably good advice in general. And again, like figuring out what it means to have something delivered or to be done with it can help, get it done, right? Another challenge that I come across is getting the legal people involved. This is normal for open source contributions, right? I mean, it's just a risk management thing. It's right. Your institution does it. Your counterparty institution does it. Everyone does it. And the common concerns are the vendors don't want to accidentally leak any of their IP to the world, right? The things that make them valuable. And they also want to understand what rights they are not giving away by, collaborating with a Kokkos backend, for example, right? And so what's useful here in this, my understanding from talking to them, is going through this a couple times, and I asked them informally afterwards, like, what could we have done to make this go a little more smoothly? And kind of the feedback I've gotten is that they do find it a little bit compelling if you have a history of doing this with other established players, which of course you're not going to have the first time. But if you have like firm guidance about the legal status of the contributions and the licensing of the thing that they're contributing to, right? I mean, obviously they would find that helpful. So what did I kind of learn from all of these things? I'd say the big things are trying to set up mutual sharing of things as quickly as possible. Partially, I think, because this is hard to do later because there's more at stake, right? There's more that you could potentially be sharing, so it's harder to do oversight of all the sharing. If you kind of start early, it sort of evolves a little more naturally. Everyone's comfortable with it. What we're kind of aiming for here is making this as low friction and as rapid feedback as possible. So it's not that everything that needs to be delivered all the time is always perfect, right? That's not the state we're in. We're just trying to get things that mostly work so we all have a common idea about what the global state of the overall effort is, right? We all want to be on the same page. We want to have a common view of the world. So I have here a couple examples of things, and a lot of these require a lot of trust. So you can't necessarily dive into this, right from the beginning of the project. But shared access to code repositories is a great way to start. So we let the vendors own this usually, and then we just have access to it. We get automatic delivery of tool chains, and sometimes you can even get kind of enmeshed in their engineering process. Once you guys are really like this with the vendor, and they really trust that you're not going to be, getting into trouble. And so all of these things are just a way to make things iterate faster and have everyone be more on the same page about what the status of the project is. The other thing that is very useful is that you can't just do everything remotely. A lot of things you can do remotely, but you can't do everything remotely, right? We've all had this experience. There's certain thorny problems that it's really beneficial to sit down face to face. So you just got to schedule this in, and I've experienced this through sort of summits with the vendor partners, but also through the centers of excellence for El Capitan. And the application teams. So I think the key takeaways, if you take away anything from this, is that everyone kind of needs to see it as a win-win, because then everybody knows that everyone's invested, right? And everyone can move forward together. The ways that you aren't successful is if you don't have a shared view of the world, right? If you don't have shared reproducers, if only one person knows the full state of various efforts. I guess another aside is just get the legal people involved as soon as possible. And the other thing is that if you assume that when you tell something to person A on the counterparty side, that person B on the counterparty side is going to have heard of it, right? This happens all over the place. I talk to one team, the other team comes to me 3 days later, and they have no idea what we discussed with the other team, right? And this happens on our side too. So I think the minimum viable collaboration kit is shared technical repositories, some kind of weekly technical delivery mechanism, so tool chains or what have you, a list of people that get escalated for different topics, and a common documentation of what the shared priorities and deliverables are. And I think if you can get these 4 things in place, you're in pretty good shape to be making pretty good progress. Thanks.
Thank you. So if you take your laptop, while we are setting up, there's maybe time for one question. Anybody?
So not a question, but a comment. I'm from a vendor. As you said, our ROI defines us being able to assign resources. HPC is often niche, so you have to think outside of the box as to where else this might be useful. So obviously HPC, we're often they have to justify their leadership allocating those resources, help give them ammo to do that.
I couldn't agree more, and I think if I get a chance to revise these slides, I'll add something about that. I think that's exactly right. I had that experience as well.
Okay. Thank you again, Carl. So, yeah.